In the humid tropics of Southeast Asia, Thailand stands out as a white gold empire. Producing approximately 5.4 million tons of natural rubber annually, accounting for about 35% of global output. With around 3.53 million hectares of lush rubber plantations, this nation is not only the heart of the rubber industry, but also a vital player in global supply chains. From tires speeding down highways to protective gloves used worldwide, Thai rubber is everywhere. What has propelled this country to the forefront of this billion-dollar industry? Let's uncover the story today. Green agriculture technology, the journey to discover Thailand's million-ton rubber industry. One of the world's most durable materials, rubber, is not only famous for its elasticity and longevity, but also for its incredible versatility. But have you ever wondered where rubber actually comes from? Watch the video to find out. The process of producing natural rubber is truly unique. Each rubber tree provides only a small amount of latex, which is insufficient to meet global demand. Therefore, large-scale rubber tree plantations are essential. First, forest land is cleared of trees and shrubs, but only to the minimum extent necessary to ensure the lowest possible environmental impact. Workers use marking ropes to determine the ideal spacing between rubber trees, preparing for careful planting. Rubber trees grow best in loose, well-drained forest soil with a cultivation layer at least 1 meter thick, allowing roots to anchor deeply and grow firmly. This soil should have a pH of about 4.5 to 6.5 and be rich in nutrients. Rubber trees cannot tolerate saline or acidic soil, so soil improvement is required if these issues arise. To plant rubber trees, workers cut healthy, disease-free stems about 6 to 10 inches long, creating angled cuts to promote better root development. Farmers can prepare budded stumps, mini stumps, or seedlings in the nursery phase. Budded stumps are cut 4 inches above the grafting point, with the main root kept at 2 inches and lateral roots around 10 inches. Mini stumps, after growing for about 6 to 12 months, are cut at an angle about 20 inches from the leaf node, with roots up to 16 inches long. When returning to the field to plant the cuttings, workers dig square holes with a minimum size of 16 inches in height, width, and length. Fertilizer is added to the hole, and the bottom of the poly bag is cut with a sharp knife. The bag is carefully removed to avoid damaging the plant. The seedling is placed into the hole, and soil is added in 3 layers, each compacted tightly. The top layer is filled to prevent rainwater from pooling around the roots. Rubber trees are usually pruned for the first time after about 2 to 3 years, when the trees are mature enough to be shaped. Pruning removes weak branches, encourages the growth of healthy shoots, and helps the trees grow uniformly in height. To ensure enough branches for latex extraction, the lower branches need to be removed. If the tree lacks branches, stimulating branch growth becomes necessary. Workers make a small incision on the trunk about 10 feet above the ground and wrap the area with banana leaves. After 1 to 2 weeks, new shoots will sprout from the incision, helping the tree grow more vigorously. The maturity phase of rubber trees begins at 3 to 6 years of age, when the trees reach a height of about 15 to 20 feet and start producing latex. During this period, the trees grow significantly in size and strength, requiring proper pruning, adequate watering, and protection from pests and diseases to maintain stable latex yields. The latex harvesting phase begins when the trees are about 6 to 7 years old, with a trunk circumference of approximately 20 to 24 inches at a height of around 4 feet. This process requires precision to optimize yield without harming the tree. Workers use tapping knives to make an angled incision of about 45 degrees downward through the latex vessels, with a maximum depth of 0.2 to 0.3 inches to protect the tree's cambium layer. A metal or ceramic spout is attached at the base of the cut to channel the latex into a cup or container hanging below. Harvesting is typically done early in the morning when the latex flow is strongest and is performed approximately every 3 days for trees aged 5 to 15 years. Mature trees over 15 years can be tapped at multiple positions around the trunk, up to a height of 10.7 feet from the ground, with a horizontal spacing of about 0.8 inches and a vertical gap of around 6 inches between incisions. To increase yield, latex stimulants can be applied directly to the cut after cleaning off the dried latex, following a specific tapping schedule. Maintaining the correct angle, depth, and frequency of tapping ensures stable latex production for about 20 to 30 years before productivity declines due to aging. After tapping, the latex is collected in rubber cups where it undergoes natural coagulation, facilitated by microorganisms. The coagulation process takes about 8 to 48 hours. A worker will inspect the latex for quality and filter it to remove impurities. Coagulated latex is processed into various forms. Cup lumps are latex coagulated directly in the cups. Block rubber is latex collected, poured into molds or containers, and formed into thick blocks. Thin sheets are created by mixing latex, pouring it into large vats, and rolling it into thin sheets. During transportation to processing facilities, rubber latex often begins to solidify. To handle this, thick rubber sheets are passed through a specialized pressing machine to flatten and shape them. The machine's rollers compress the rubber into thinner sheets, facilitating further processing. After shaping, the thin rubber sheets are hung on racks to dry naturally in a well-ventilated space. After undergoing preliminary processing, rubber is compacted, baled, and transported to factories for further processing into various rubber products. Upon arrival at the processing facility, rubber sheets are unloaded and fed through a pressing machine where they are flattened by two rollers. These sheets are then cut into required sizes using cutting machines. Preparing them to be used as liners for steel pipes. The pipes are mounted onto rotating shafts, and the rubber sheets are automatically fed between pressure rollers to ensure perfect adhesion and a smooth surface. Next, the rubber-lined pipes are placed in pressure chambers or autoclaves, where they undergo heat and pressure treatment. This process hardens the rubber, permanently bonding it to the steel and activating the necessary properties for the final product. The pipes are then hand-painted and processed in a laser labeling area, ensuring each pipe has a unique label ready for distribution. Have you ever witnessed the production process of rubber gloves? The production of rubber gloves begins with the preparation of natural or synthetic rubber. Mixed with additives such as plasticizers and preservatives to enhance the rubber's properties. Once mixed, the rubber is poured into glove molds that have been cleaned and sterilized. These molds are dipped into the rubber solution, then solidified and cured in an autoclave to form the glove's shape. The gloves are then removed from the molds, washed, and dried. Some gloves may be coated with a fine powder or silicone to facilitate easy removal and use. Finally, the gloves undergo thorough quality checks, are packaged and distributed. This process requires precision and strict control to ensure high quality and safe products for users. The soft latex mattress you are familiar with, providing you with comfortable sleep, is the result of a meticulous production process. Latex mattresses are made from natural or synthetic rubber, mixed with additives to achieve elasticity and flexibility. This mixture is poured into molds and compressed under high pressure to form uniform rubber sheets. After pressing, the sheets are cured in autoclaves under controlled temperature and pressure to harden and stabilize their structure. The rubber sheets are then cut and shaped into the desired mattress size. Finally, the mattresses undergo quality inspections, cleaning, and packaging for distribution. This process ensures that the mattresses are durable, highly elastic, and safe for users.